My name is Anwar bin Mohammed, with matrix number of EA18122. Now I will present about a channel encoder of binary modulation, specifically about PSK. So, in this video, I will show you how Qpsk or quadrature of phase shift keying is formed. So as we know that Qpsk consists of two BPSK or binary phase shift keying. As we know that BPSK phase shift keying is only 180 degree or 90 degrees, depends on the carrier carrier function. If you use cosine, you will get 90. If you use sine function, you will get 180 of phase. So how PSK is formed? If you use the Simulink, you can use the switch function here and you get the PSK, and you can easily use the multiplier to get the PSK. I prefer the multiplier as I use it in my coding program. So this is my BPSK. I will show you how this Qpsk is formed. So firstly, if we receive the binary inputs up to 10, which is consists of 1 0, and the number of this 1 0 consists of 10, let me show you the plot diagram. Okay, if I receive the input of 1 0 here, I can use the pen. And I will map it into the non-written 0 and RZ coding. If the input is 0, so it will be mapped into the -1. So this is the amplitude. Okay, and if the binary input is 1, it will be mapped into +1. So this is represent 1, and then they will be splitted into the even and odd bit. After that, as you can see here, this is B. So as let's say that the time taken for the 10 bit is 10 seconds. So for 1 bit, it takes 1 second. So as we can see here, why 2 TB here? Because they are already splitted. So 5, but the time is the same, 10 seconds. So how to complete the one bit is 2 seconds. Okay, this is how I do it. It's like this. This is how I do it. Let's say this is 0 and this will be 2. Okay, they will disappear later. So after they are splitted into even and odd, it will be multiplied, as I mentioned before, by the crystal oscillator. This crystal oscillator will produce the carrier function of cosine and sine function respectively with the same frequency. And then after they are multiplied by sine and sine multiplied by the odd, they will form BPSK. So for the cosine, the phase will be shifted to 90 degree. Meanwhile, the sine, the phase is shifted to 180 degree. Okay, and then they will move to the adder block. Just add this acts like the adder here. Okay, and then after that, Qpsk is formed, and so we can say that the cos multiply even bit will minus the odd multiplied by the sign. Okay. So as we can see before, how I use it, the even bit. Let's say I name it 1t multiplied by the cosine, okay, 2 pi ft. Then this is my BPSK one. Then it will minus. Let's name it the odd of t. This is this dot and multiplied by the sine. Okay, 2 pi t. Let's just name it CFC. So this will produce the Qpsk waveform. Qpsk. Okay. In my MATLAB, and this is my GUI figure as I designed before. It consists of 5 axes, 2 inputs, and 1 push button, 1 display of odds and even. Okay, move my view to the orientation, and then as I could explain before, I start at this is my random input. Okay, randy stands for random binary inputs up to 10. Okay, up to 10. I can put it 20, so for the easy visualization I just put it 10, and it will display on this display this here. This is my random binary input. Okay, and then this is the NRZ polar mapping. It's NRZ polar mapping. If the function reads 0 of input, then it will be mapped into -1. Else, or if it reads a 1, the amplitude will be 1. So -1 represents 0, 1 represent +1. Okay, and so it will be separated for even and odd sequence here. So as you can see, I start with 1 for the odd and 2 for the even, and the gap of 2, because as I mentioned, we can see that it is 2b here. So that's why I put 2 here in the middle, not 1. So this is my mapping of this is for the odd sequence and the even sequence, as you can see here. Okay, in the middle here I put the gap between the numbers before and after is 2. Okay, because I want 2 dB as I mentioned before, and then I plot them on axis 1 and axis 2 of even and odd bit. Axis 1, axis 2 is binary input, and I declare my carrier function both are cosine and sine function respectively, and they will be multiplied to form BPSK function. So the even sequence will be multiplied by the C1. C1 is my cosine function. Meanwhile, the R2 will form the BPSK2, which is the odd sequence here, will be multiplied by the sine function. So C2 represents sine function, and then the QPSK equals to R1 minus R2. So R1 minus R2 is this. R1 minus R2. Okay. So let's run it. Okay, let's put 1, 2. Let's just put 1, and then I simulate my coding. So this is just random binary input. Just I can click few times to get a different output. Okay, this is how it works. Okay, how it works. So as you can see here, BPSK of even B input, it starts at 1, binary input of 1, even 1, okay, even 1. So cosine, it will start at 1. If this starts at -1, which is 0, it will start at -1. So time equals to 2. There is a transition of 1 to -1. So the phase will be shifted to 90 degree. So at time 2, it starts at -1 from when it is transited from 1, and then 2 up to 6, there's no transition, there's no phase. The phase is still 90 degree, and then up to 6, the transition is changed from -1 to 1, -1 to 1. And then of course the cosine function will start at +1, and it will be shifted again up to the end. So as we can say, this is a sine function. This is inverted sine function, because as you can see, this is binary of 0. 0 represents -1 volt. So negative, it will move to the negative. It will start downward up to negative. Okay, and then at when time equals to 6, it will be shifted to 180 here, 180 degree, and until the end. So how I read this Qpsk waveform after they are both added or subtracted? So what does this mean? It starts like this, and then time 2 start like this. So we can say that the first two here start with 0, 1. Okay, 0, 1. It will start as I do my own. This is my own design. How I get this? When I get 0, 1, I get the phase of 45 degree. So 45 start like up, move upwards and then downwards until the end. And so when um, time from 2 to 4, I got 0, 0. Okay, 2 to 4, 0, 0. So 0, 0 is the phase of Qpsk of 0, 0 is um, 315 degree, or negative 45 degree. It will start at negative and move to upward. Like this, I can show. It start at negative and move upward. Okay, and then up to 6. There is the transition here when the input is 1, 1. Okay, this is Qpsk. So Qpsk will start at 0, 1, 2, 3. So the bit here is 3, on we can say in binary is 1, 1. So 1, 1, how I get it is 135 degree. It will start at positive and move downward, start at positive and move downward. Okay, when I got the 1, 0 of input, I will get like this to the 1 negative, it will move downward. Okay, how I analyze in my Cartesian I. So if I get 0, 1, it will be shifted 45 degree. Okay, shifted 45 degree. It will move upward to downward. If I get 0, 1, so where is my 0, 1? There's no 0, 1. Let's forget it. But why? If I get 1, 1 or 3 in decimal, it will move from positive to the negative. Okay, I get 1, 1 here. It will move from positive to the negative. 1, 1, positive to the negative. Okay, this is how transition of the Qpsk. And if I get 1, 0, it will start at negative and move downward and back to upward. Okay, like time equals to 8 here. It will start at negative and move downward. So 0, 0, it will start from negative and then it will move upwards. Negative, it will move upwards. So be noticed that the downside here is negative value and the upside is the positive value. So here's how I analyze it. So let's say, so this is how it starts at like this when I got a 1, 1 binary input. So 1, 1 input. 1 binary input, I will start at 1, 3, 5 phase from positive to negative and back to positive. Okay, 1, 1, positive to negative, back to positive, back to negative. And then 0, 1, 0, 1, I get 45, 45 will start at positive. Okay, that's how I analyze my Qpsk. Because Q quadrature stands for 4. We start at 0 up to 3, 0, 0 up to 1, 1. Okay, and that's all. This is my explanation. Thank you very much.